Hello, my learners. Welcome back to Sir Daniel's Maths and Science class. Let's solve this science problem on the board. Okay, so the question says, in a machine, an effort of 5 Newton is applied to raise a load of 20 Newtons. If the load moves through a distance of 3 meters, when the effort moves through 15 meters, find I, the mechanical advantage, II, the velocity ratio, and III, the efficiency of the machine. Okay, so this question is coming from machines. So let's write down all the meaningful information from the question before we start to solve. Okay. So in a machine, an effort of 5 Newtons. So the effort of the machine is 5 Newtons. So solution. So from the question, the effort of the machine equals 5 Newtons. It's applied to raise a load of 20 Newtons. So load from the question. Load equals 20 Newtons. Let's continue. If the load moves through a distance of 3 meters, so this one becomes the load distance. So load distance equals 3 meters. When the effort moves through 50 meters, so this also becomes the effort distance. Equals 15 meters. Okay. Find I, the mechanical advantage. So I, mechanical advantage. Okay, so mechanical advantage is one of the properties of machines, and then mechanical advantage is expressed mathematically as the load divided by the effort. So mechanical advantage equals load divided by the effort. So let's substitute this one into the formula. So from the question, the load is 20 Newtons. So load 20 Newtons over effort. So the effort is 5 Newtons. Good. So 5 goes to itself 1, goes into 24 times. Therefore, the answer is 4. Therefore, the mechanical advantage of the machine is 4. Mechanical advantage, it doesn't have a unit. Okay, let's continue. II, the velocity ratio. So II, velocity ratio. Okay, so velocity ratio is also expressed mathematically as the effort distance divided by the load distance. So velocity ratio will be equal to effort distance all over load distance. Okay, so let's substitute the values into this formula and find our answer. So the effort distance from the question, the effort distance is 15 meters. So this gives us 15 meters divided by the load distance. From the information that we gathered here, the load distance is 3 meters. So divided by 3 meters. Okay, so 3 goes to itself 1 time, and then goes into 15 5 times. So 3 times 5 is 15. Therefore, the answer is 5. So the velocity ratio equals 5. Velocity ratio also does not have a unit. And then the last one, the efficiency of the machine. Efficiency of the machine. Okay, so we have different formulas we can use to calculate efficiency, but based on the values that we are having here, the right formula we can use for efficiency is mechanical advantage divided by the velocity ratio times 100%. So efficiency equals mechanical advantage over velocity ratio times 100%. Now let's substitute the values into this formula. So mechanical advantage from the question, We just solved it. Mechanical advantage is 4. So mechanical advantage will be equal to 4 divided by velocity ratio. So the velocity ratio, we got 5. So over 5 times 100%. Now let's break it down. Okay. So 5 can go to SF1 and then goes into 120 times. And then 4 multiplies 20 to give us 80. Therefore, the efficiency of the machine is 80%. So if you found this one helpful, like, comment, subscribe for next episode. Thank you.